All right, next section is 4.3. We're looking at trigonometry extended, the circular functions. And the first thing that we're looking at is coterminal angles. Coterminal angles are angles that end at the same ray. So starting on the positive x-axis and rotating at a certain angle measure, the final or terminal ray ends in the same place. The way we can determine if two angles are coterminal is by subtracting or adding multiples of 360, because 360 is a full rotation. So if we're looking at the first angle is 150 degrees, that's already within one rotation. So 510 degrees is more than one rotation. If we subtract 360 degrees from it, we will find that we have a value of 150 degrees. So we know that these two angle measures are coterminal. For negative 210 degrees, it's negative, so we would like to add 360 to it. And when we do that calculation, we find that we also end up with 150 degrees. So all three of these angles are coterminal, and I will leave it to you to find out if the other two are also coterminal. Sometimes you have to add or subtract multiples of 360, so you might have to add or subtract 720 to one of these in order to find out if they are coterminal. Looking at example 2, we want theta to be an acute angle in standard position, meaning that its initial side is the positive x-axis and the terminal side contain the point 5,3. Find the 6 trigonometric functions of theta. So let's start by drawing our triangle. 1, 2, 3, 4, 5, 1, 2, 3. So we know that this is our angle theta, and this is our right triangle with legs 5 and 3. Using the Pythagorean theorem, we can find our third side. 9 plus 25 is c squared. 34 is c squared. So c equals the square root of 34, which is our hypotenuse. All right, so looking at theta, then we can find that sine of theta, which is, again, opposite over hypotenuse. So opposite is 3, divided by hypotenuse is the square root of 34. And then we rationalize, so that's 3 times the square root of 34 divided by 34. 3 does not go into 34, so this is reduced form. Cosine of theta, which is adjacent over hypotenuse, 5 divided by the square root of 34, which is 5 times the square root of 34 divided by 34. Tangent of theta. Tangent is opposite over adjacent. That's 3/5. Then we have cosecant of theta, which is the hypotenuse divided by opposite, which is already rationalized. We have secant of theta, which is the hypotenuse divided by adjacent. And we have cotangent of theta, which is adjacent divided by opposite. And these are your final answers. All right, the next example, number 5, is on the next page, and we're looking for the 6 trigonometric functions of 315 degrees. Notice 315 degrees is an obtuse angle, so this is going to be a little bit different than what we did in 4.2. First, let's draw our angle. 315 degrees is in quadrant 4. And what we want to do is find what's called a reference triangle. And that is finding from our terminal ray to the x-axis a new triangle. So here is our reference triangle, and it's a right triangle. And what we want to find now is our acute angle theta. Since a whole rotation is 360 degrees, and our angle was 315 degrees, we can find theta by calculating 360 minus 315, which is 45 degrees. Okay, so now we have our reference triangle, which we can redraw here right triangle with a 45-degree angle. Now we know that that means this is also a 45-degree angle. So we have a 45, 45, 90 triangle. And just like in 4.2, we can say let each of the legs have a length of 1. Then the hypotenuse would have a length of the square root of 2. Now the difference here is that 315 degrees is an obtuse angle. So if we label those lengths here, this is a positive 1, but now we're on the negative y-axis. So this length is actually, the value here is negative 1. And our hypotenuse is still the square root of 2. So when we calculate our trigonometric functions, we have to take into account that this leg is negative 1. So let's find sine of 315 degrees. Sine is opposite over hypotenuse. So that's going to be negative 1 divided by the square root of 2. When we rationalize that, we'll have negative square root of 2 divided by 2. For cosine of 315 degrees, we have adjacent over hypotenuse, which is 1 divided by the square root of 2. Rationalized, that gives us the square root of 2 over 2. Then we have tangent of 315 degrees. Tangent is opposite over adjacent, so we have negative 1 over 1, giving us a value of negative 1. Let's do cosecant of 315 degrees. Cosecant is hypotenuse over opposite. So that's square root of 2 divided by negative 1 gives us negative square root of 2. And then secant of 315 degrees, which is hypotenuse over adjacent, square root of 2 over 1, which gives us the square root of 2. And finally, cotangent of 315 degrees, which is adjacent over opposite, which gives us a value of negative 1. All right, so notice some of our values here are negative, which in acute triangles we did not have any negative values for our trigonometric function. For example 6, we'll use the same process, except we're finding only specific functions. So we don't need to find all 6 again, just the ones given. And notice some of these are in degrees and some of them are in radians. For example 7, we're finding cosine and tangent of theta by using the given information to construct a reference triangle. Remember, a reference triangle is what we made in example 5, where it's the terminating ray to the x-axis. So given that sine of theta is 3/7 and tangent of theta is less than 0, so tangent is a negative value, we can discover what quadrant and then we can build our reference triangle. So if tangent is negative, we know it can't be in quadrant 1 because all of our trigonometric values were positive in quadrant 1. We know it can't be in quadrant 3 because tangent is positive in quadrant 3. And then since sine is positive, we know it can't be in quadrant 4 because sine is negative in quadrant 4. So that leaves us in quadrant 2. So we can build our terminal ray here. And we know that our reference triangle is going to go from our ray to the x-axis. So there's our reference triangle. And if we have sine, where this is theta, sine is opposite over hypotenuse. So that would be 3/7. So we have now our reference triangle and we need to find our third side. We can use the Pythagorean theorem for this. 3 squared plus x squared equals 7 squared. 9 plus x squared equals 49. X squared equals 40 by subtracting 9 on both sides. So then x equals the square root of 40. We only need the positive value. Now I know that 4 is a perfect square, so I could simplify this further to x equals 2 times the square root of 10. Okay, notice this is on the negative x-axis, so our value here is negative square root of 40, or negative 2 times the square root of 10. All right, the distance of that leg is the positive square root of 40, but because it's on the negative x-axis, on our reference triangle, that leg is negative square root of 40. So let's go ahead and find cosine of theta. Cosine of theta is adjacent over hypotenuse, so I have negative square root of 40 divided by 7, which is already rationalized. All right, now let's find tangent of theta. Tangent of theta is opposite over adjacent, so we have 3 divided by negative square root of 40. This does need to be rationalized, so I'm going to use our simplified version. So this simplifies to 3 divided by negative 2 times the square root of 10. To rationalize this, I have to multiply both numerator and denominator by the square root of 10. So this becomes 3 times the square root of 10 divided by negative 2 times 10, which simplifies to 3 times the square root of 10 divided by negative 20. And those are the final answers. Using this same process, you'll complete the other 2 parts of example 7. Since the trigonometric functions come from the unit circle, they are periodic, and that means that they repeat. Sine and cosine repeat every 2 pi, and tangent repeats every pi. So that means sine and cosine have a period of 2 pi, or 360 degrees, and tangent has a period of pi, or 180 degrees. And how we can use that is that we can simplify these arguments, and if we can remove factors of 2 pi, then we can simplify the argument. Let's start by rewriting it. So I can say that this is equal to sine of, notice our numerator has an odd factor, so I'm going to rewrite this as pi over 2 plus 57,800 pi over 2. Now I'm hoping that this will reduce into an even number, and because it's a multiple of 100, I know that it will. And that means that we can actually just remove that part of the argument because it's a full cycle, it's a full period. So this will become sine of pi over 2 plus 28,900 pi. Because this is a multiple of 2 pi, it is cyclical, it is a period, and then we can just simplify this to sine of pi over 2, and we know that sine of pi over 2 is 1. Using the same method, you can do the other 2 problems. Remember that the period of tangent is pi, not 2 pi, so you can remove any factors of pi as one cycle. And in this case, you may need to simplify both separately before doing the operation of subtraction. That's the end of section 4.3. So in this box, reflect and then write a summary of what you learned from this section.